in this class, I want to discuss something which I believe is as important as knowing the chain rule is. This shortcut, I actually call it shortcut, but it's very important as the chain rule is, because there's sometimes you have some very bulky function to differentiate. You can't be going through that route of using let u equals to f of x, let t equals to this. It gets confusing if you have function of a function over layers of function. So this is what we're going to do. This is just like spiral. This technique it's like spiral. You know Archimedes spiral now. So it's just like spiral. So how do you differentiate function of a function whereby it's function of another function inside a function that is another function? Got it? So imagine you have a function y equals to sine squared x squared plus 4. This is a function of another function inside of a function. So how do you differentiate this? I call this technique is that first, this is the same thing as sine x squared plus 4, everything raised to power 2. So how to differentiate this is that you start differentiating from the outer function. So then you differentiate the layer below it. Then you differentiate the function, the layer below it. So what I'm trying to say is that, look at this, sine x squared plus 4, everything raised to power 2, that is squared. So to differentiate that, first you differentiate this. Derivative of this sine x squared plus 4, everything squared, will be equals to 2. First you differentiate with respect to this. 2 sine x squared plus 4. Then you differentiate with respect to sine inside. Derivative of sine is what? Cos. That's cos x squared plus 4. Then you differentiate the angle that we have inside that sine, that is the x squared plus 4. Derivative of x squared plus 4. Derivative of x squared is what? 2x multiplied by 2x plus 0. So that's the derivative of this function. It becomes easier like this if you go through this route than saying let u equals to x, let u equals to one thing. So that is sometimes it gets confusing if you have a function that is really bulky. So we have this to be 2 multiplied by 2x, that's 4x sine x squared plus 4 cos x squared plus 4 sine x squared plus 4 cos x squared plus 4. So you can leave it like this, or if you are very vast in trigonometry, remember we have what we call the double angle formula. All this cos 2 theta equals 2 sin theta cos theta. So we are very vast in trigonometry. So you can still change those two. Remember that cos 2 theta equals to 2 sin theta cos theta. We have half angle formula, double angle formula like that. So if you remember that. So from here now, it means we can change this 4x sine x squared plus 4. That is factorize out, bring out 2x. It can be written as 2x multiplied by 2 sine x squared plus 4 cos x squared plus 4. So which is the same thing as 2 sin theta cos theta. So if 2 sin theta cos theta is equal to cos 2 theta, that implies that 2 sin x squared plus 4 cos x squared plus 4 will be equal to cos 2 x squared plus 4. Follow this, please. Cos 2 x squared plus 4. So in this case, x squared plus 4 represents our theta. Get that? So 2x multiplied by 2 sin x squared plus 4 cos 2 x squared plus 4. So from this, cos 2 theta equals 2 sin theta cos theta. So imply that 2 sin x squared plus 4 cos x squared plus 4 will also be cos 2 x squared plus 4. So which will be now equals to 2x cos 2 into bracket x squared plus 4. So it's not compulsory to solve it up to this level. Once you arrive at this, then it's still a correct answer. So but what you will find is that some textbooks will go for that. You will just realize that this is not the answer that they have. They have this as their answer. So that is using trig. So that's what they do. So that's it. So another thing that so let's solve another question. Let's say if y is equals to sine square root of x squared plus 4, or sine cube square root of x squared plus 4, sine cube root x squared plus 4, if y is equals to this. So this will be very complicated if you decide to use chain rule and select u equals to sine this. So it's not that you can still go the route of using chain rule and all that, but it becomes confusing because you have multiple chain rule inside this, and it becomes a chain that is sometimes you don't understand it anymore. So this is the same thing as sine square root of x squared plus 4, everything raised to power 3. Everything raised to power 3. So how do you differentiate this? Remember the spiral. First, you differentiate with respect to what is outside. Then you differentiate with respect to this. Then you differentiate with respect to this. So you get that. So from here now, the derivative of that will be equal to 3 sine square root of x squared plus 4 squared, that is 3 minus 1, multiplied by, so you differentiate with respect to sine. So the derivative of sine x squared plus 4 will be equal to cos square root of x squared plus 4 multiplied by, so you differentiate with respect to this. So you differentiate this polynomial function that we have here. So square root of x squared plus 4. How do you differentiate square root of x squared plus 4? Remember that x squared plus 4, square root of x squared plus 4 is the same thing as x squared plus 4 raised to power half. So to differentiate that means multiply by, you bring this half here into bracket, x squared plus 4 raised to power half minus 1 multiplied by, so you redifferentiate what you have inside. Don't get confused. So differentiate x squared, that's what, 2x plus 0. So from what we have here, you can see this is a very, very long solution we are dealing with here. So we have 3 sine square root of x squared plus 4 cos square root of x squared plus 4. So multiply by, from here now, 2x, 2 cancel 2. So we have x multiplied by x into bracket x squared plus 4 raised to power half minus 1, that's minus half. So from what we have here, this is the same thing as you have 3x, bring that x here, sine squared square root of x squared plus 4 cos square root of x squared plus 4 multiplied by, so if you remember from indices, so a raised to power minus m, from indices, a raised to power minus m is the same thing as 1 over a raised to power m. So if you apply that, that means x squared plus 4 raised to power minus half is the same thing as 1 all over x squared plus 4 raised to power half. So what we have here now, our solution becomes, remember that x squared plus 4 raised to power half is the same thing as square root of x squared plus 4. So then we have all of this all over. So then our solution will be equal to, that is d dx of sine cube square root of x squared plus 4 will be equals to 3x sine squared square root of x squared plus 4 cos square root of x squared plus 4 everything all over square root of what? X squared plus 4. That is the solution. This is all about the shortcuts. We are going to be using this a lot in our next classes. So I'll see you in the next class.